Hey, how's it going? So, I'm just going to be talking about what compliant mechanisms are and why they're pretty cool. So, what is a compliant mechanism? It's a one-piece mechanism. It achieves what a multiple piece mechanism would be able to achieve, but through only one piece, which means it basically achieves that through bending, very specific bending. So, why would we want to use these one-piece mechanisms instead of these multi-piece rigid mechanisms? There's actually many reasons. I'm gonna go through 2 scenes just to kinda give you an idea of, a concrete example of why you might be interested in them. But, um, but yeah, I'll just be narrating over that. So first off, you can actually achieve things that you wouldn't normally be able to achieve with rigid mechanisms. A great example of this is this sine surface. So this surface here, um, is basically an output. I have an edge of the design domain as an output given a specific input force. So if I were to ask you, hey, maybe I'm working in optics, maybe I'm working in semiconductor manufacturing, something. I need this surface to be modulated based off of say 1 degree of freedom input, maybe like a linear actuator or something. If you were using like rigid components, how would you do that? That'd be very hard. With this app, it's actually very easy. So right here, I just prescribe this surface to have a specific displacement. In this case, it's a sine function with a given wavelength and amplitude. And then I have this input preserved down here that is actuating this output surface. And then I have mounting on both edges here. This is just a test. You'd have to actually mold it to your use case. But yeah, this is I think an effective test. So you can see you put in those objectives and then you get this result. And so this result is showing that it's actually very easy to design this surface if you use the app and start with just objectives instead of trying to piece together a design on your own. So that's a benefit. The benefit is very complex motion made easy through worrying about the objective. There's also a benefit of iteration time. So if I want to say completely redesign this mechanism to have the same sinusoidal surface, but I need it in a completely different area. Say like the left side of this mechanism, I can just go in and edit that, and then I get this great result, same input, different results, same sine function, now on a different edge. So that's really a benefit as well. What else can you do with compliant mechanisms? So compliant mechanisms can be used to kind of replace what you'd normally use rigid mechanisms for. There's some benefits that come along with that. So just to illustrate that, I have this gripper here. So I'm just going to hide the actual design and show you what I used to make it. So to make it, I have these red areas, which is where I'm mounting the gripper. The blue is the input, again, 1 degree of freedom. And then the yellowy regions here are the output. So in this case, the object would go between them. I would grip it by pulling back on the blue region. So this is something for an end effector of a robot or something like that. And then I have this area here, this gray box, which is a keep out region. So obviously that's where the object would go. So we can't fill it with material. So why would we design something that can be normally done with with rigid components with a compliant mechanism? Well, that's a great question. Really, it comes down to a few things. So first off, you might not actually care about the design. You just want it to be done. You have a set of objectives of what this part needs to do, but you don't want to have to actually source the components to make that. So this is a great option for you because you can basically just throw these preserves onto this design domain and then hit run, and you're going to get something that you can water jet, something that you can CNC, something you can 3D print, manufacture in some way very simply, very quickly. So that's a benefit. Then there's also the benefit of some more inherent benefits of compliant mechanisms that might not be as apparent. So some things you can notice. I'll show you the result here. Okay, yeah. So here's the result. Um, we can show the animation, but basically because there's no components that are amalgamated to make this mechanism, you don't have to worry about interfaces, which means you don't have to worry about backlash or lubrication. So that could be great for two reasons. One, you just don't want to have to worry about that because you want to get some project done quicker. Or two, you can't tolerate the lack of precision that comes with backlash or the wear over time that comes with you know relative motion between parts. So so yeah, so you can make this gripper that basically has a life that's equal to its fatigue life, and you don't have to think about it otherwise. So that's really those are some benefits that might not be apparent, from the get-go, but definitely something that you would want to keep in mind. So these are just two examples. There's many more that we could go over, but we're actually looking for people to give us more use cases so we can demonstrate real world applicability. Um, but yeah, yeah, there's a lot you can do with this. This is just scratching the surface. The solver is very robust, and if you need any help with anything, or if you have any more questions, definitely reach out. We're very responsive.